This is the continuation of our lecture for domain and range of composite function. Now, why is this this f of g of 8 is undefined? Now, in our case, we got g of 8, which is equal to 8 minus 3 is equal to 5. And performing all of these operations here, this is a bit tricky, okay? Because performing all of the operations here, okay, and presenting you all the domain restrictions. Now, our 8, which is in G, the value of x is equal to 8 for our G of x. Notice that, you know, the x does not appear here. Okay, it is outside the domain of our G of x. Now, because it's outside the domain of our G of x, then it could not be taken as very, you know, relative to our f of x. So if it's 8, meaning that it's outside our domain for G, which is only from 2 to 7. Now the given x value is equal to 8. Therefore, this is undefined. If you look at your grapher, take a look at your grapher, okay? Your grapher would say that the value f of g of 8 for the certain domain restrictions, x in between and equivalent to 2 and 7, and f of x, which is a domain of x in between and equivalent to 1 and 5, we have our f of g of 8. Your grapher will just say it's an error or does not exist, D and E, or does not exist. And therefore, because it is an error or does not exist, because in the first place our x is equal to 8 is absent in the domain restriction for g of x, then our f of g of 8 is, of course, undefined. And that completes our requirement for letter B. Now we go to letter C. Try to find f of g of 2 and explain why this value is undefined, even though 2 is in the domains of both f and g. Now we go to the basics again. Our g of 2 here is equal to 2 minus 3, and 2 is in the domain restriction of our g of x. Therefore, it is valid for g of x. So g of 2 is equal to -1. Because g of 2 is equal to -1, our f of g of 2 is equal to -2 times -1 plus 8, which is equal to 10. But again, this is a bit of a tricky example because -1, and look that our g of x is now contained into our f of x. So our g, then meaning that our domain for the f of g of x would now be for this part. And in this case, our g of 2 is -1. And -1 is not included in the domain restriction for f of x, which is only from 1 and 5. So this makes our f of g of 2 undefined. F of g of 2 is undefined, does not exist, or error on your grapher, because the domain restriction only states the values from 1 to 5 for f of x. And surely g of 2, which is equal to -1, is not in the domain restriction of our f of x. So this completes our requirement for letter C. Let's go to letter D. Plot f of g, and g of f on your grapher. If you're going to graph f of x, g of x, f of g of x, and f of g of f of x, This one should be g of f of x. So on your grapher, just try to graph f of x, which is the broken line here. Okay. This broken line here. Our g of x, which is the broken line here. And our f of g of x, which is our y3, which is this one. And our y4, which is this one. Okay, your grapher should have the same illustrations or graphs as mine. Now, if the domains of two functions are restricted, then the domain and range of the composition of those two functions are also restricted. I'm going to show you to graph the four functions in the grapher. As you can see, this is the grapher that you can. This is our grapher. This one. Okay, and we're actually graphing our four functions: our f of x, g of x, f of g of x, and g of f of x. So look here, we have negative 2x plus 8 with domain restrictions from 1 to 5, and our y2 is equal to x minus 3 with the domain restrictions from 2 to 7. So just insert your y1 and y2 as you can find here. Okay, just perform this y3 for y1 of y2 and for your y4, y2 of y1, and you will have the same figure as you can see here. We have this one, this one, this one, and that one for all the graphs. So giving us this whole thing of the plotted graph of the four functions f, g, f of g, and g of f on our grapher. Our requirement for letter E is to find an equation that expresses f of g of x explicitly in terms of x. So going back to the basics again, our g of x, as we know it, is equal to x minus 3. Then our g of x then would be, or our f of g of x then would be equal to okay, my pen is not working properly. Okay, so our f of g of x, f of g of x now would be equal to f of x minus 3 actually, and that's equal to negative 2 times x minus 3 plus 8, which is equal to negative 2x plus 6 plus 8, giving us an equation which is totally a different equation from the original functions. We have f of g of x is equal to negative 2x plus 14. That's our f of g of x. So this is our equation. Now, the challenging part here is to find our domains and ranges for our f of g of x, which is equal to negative 2x plus 14. To find our domain for f of g of x now, we will have to get the domains of our g of x and our f of x. Now we're going to do it by using a linear line or the real number line. Consider this as our real number line. So this is for g of x. and this is for our f of x. Okay, so I have a real number line here for f of x, for the domain of f of x, and for g of x. Let's say this is for f of x, and this is for g of x. Now our domain restriction for g of x is from 2 to 7. So if this is our 0, 1, 2, 3, 4, 5, 6, 7, it's exact. Okay, and our domain restriction for f of x is from 1 to 5. So if this is our 0, 1, 2, 3, 4, 5. Let's say 6 and 7. Okay. Our domain restriction for g of x is 2 and 7. So because it includes 2 and 7, so it's here. Okay, and our domain restriction for f of x is 1 and 5. So 1 and 5. Okay. But how do we determine the domain for f of g of x? Notice that our domains for both functions g of x and f of x matter for this portion. And we already have the illustration for the real number line for the domains of f of x and g of x. Now what we are missing is the domain for f of g of x. But remember that when we do the f of g of x composite function, our g of x now would be in between the domain of our f of x. It would be contained in our domain for f of x. Now our g of x is equal to x minus 3. So we have to have something like this expression. Okay, what we are going to do here is to get an x term or an x expression on the middle. So we're going to transpose the negative 3 to the opposite side. I mean opposite sides, both sides, okay? So that would mean that we're going to add 3 to each of the terms given here. So 3 plus 1, x minus 3 plus 3 also for the middle. That will cancel our negative 3 here. And our new domain would be in between 4 and 8. So it's a totally different domain restriction now. Now, what do we do with this domain restriction? We're also going to have to graph it on a real number line. So, following the same with our graphs here, with our given real number line graphs. So, let's do it. We have another set here. If this is our 0, the beginning, 4, 5, 6, 7, 8. This is totally 8. Okay, let's add 2 more here. So we have 0 in the middle, 1, 2, 3, 4, 5, 6, 7, 8. So our domain for our f of g of x is indicated by x in between, but including 4 and 8. So as you can see here, we have 3 domain restrictions here. So if we have 3 domain restrictions, what do we want to get here? We want to get a domain restriction which is true for all the real number lines being drawn here. So let's erase the grid. And then we would find that let us have some illustrations for our domain restrictions. For f of x, this is our domain restriction. for g of x, our domain restriction would be from here, from 2 to 7. And for our f of g of x, our domain restriction is from 4 to 8. So our domain is the intersection of g of x and also our f of g of x. Therefore, this is one thing that you should really consider, okay? Your f of g of x domain and your g of f of x domain. So this is our f of g of x. Both domains must lie. They must be an intersection of both g and x and f of g of x. So in this case, note that our intersection for g of x and f of g of x would be from 4 and 7. This is where they are common. So our new domain now would be, to put it, our domain now would be from 4 to 7 indeed. Okay, so x in between and including 4 and 7. Now, how do we find the range? If our domain, new domain now is equal to in between our 4 and 7, okay, it's in between 4 and 7, then our range would be, if our x is equal to 4, then our f of g of x, which is equal to negative 2x plus 13. So if it's equal to 4, that means that we have negative 2 times 4, that's negative 8, plus 14, that's 6. So if x is equal to 4, y is equal to 6. If x is equal to 7, let's take a look at the limits. Okay, we have 4 and 7. If x is equal to 7, then our g of x or f of g of x would be equal to 0. Therefore, our range now would be taken from 0 to 6. We have to include this portions here. This portions. So our range would be in between 0 and 6. That would be our range for f of g of x is equal to negative 2x plus 13. Therefore, our values for the range could be written as y in between 0 and 6. This is our range restriction. Oops, what did I do? Okay, so that is our range restriction from 0 to 6. So from 0 to 6. Okay, to summarize this, to get the equation, first you have to substitute g of x to our f of x, and our g of x is equal to x minus 3. We plug it in to our f of x, and we get negative 2x plus 13. Now to get the domain, which is very, very important, we have to consider the domain for our g of x, because this is what is being contained in the f of x. And after that, we get the g of x to be sandwiched in between our domain restriction for f of x. And so we get domain restriction initially at 4x8. But notice that this domain restriction for our f of g of x should also coincide with the domain of g. In other words, they should intersect with the domain of f of g. So our new domain now, as you can see it, the one here, and I'm going to make it bigger for you. Okay, this whole thing here, you can see the intersection of our g of x and f of g of x, and that's equal to the x value from 4. Oh my god, what is this? Okay, so from 4, okay, x and 7. It's in between 4 and 7. So that completes our requirement for letter E.